Alrighty, guys. Next part to our lesson for today is the concept of percent yield. So, percent yield is a way to determine how good your particular reaction is. This particular equation that's on the screen is also on your cheat sheet, so you don't necessarily have to worry about memorizing it. But percent yield is the actual yield over theoretical. So the thing about this is that your actual yield, oh, my tablet turned off. The actual yield comes from what you do in the experiment. So this would be what you physically make. Your theoretical yield is always whatever you calculate. So I don't know if you guys remember my analogy way back early in stoichiometry when I was talking about muffins. When I make chocolate chip muffins, I always get 11 muffins because I eat some of the chips before they ever make it into the muffins. But my muffin container says that I'm supposed to get 12 muffins. So 11 divided by 12 times 100 would be how I would calculate my percent yield for this particular reaction. Oh, of course, it doesn't want to work. It's 100, not minus 100. Alrighty, third time's the charm. 11 divided by 12 times 100 equals 91.6% yield. So, roughly 92%. That particular experiment of muffins, was a pretty good experiment. I produced pretty close to what I was expecting to make. Um, since we're not physically doing experiments in the lab, the number on the top is going to be given to you in the problem. It's going to tell you what the student or what you made or what the scientist made in the lab. So this is always going to be in the problem. And you're going to always have to do the calculation for theoretical yield. So this is something you're going to have to calculate. So we're going to combine percent yield with limiting reactant to give us a chance to kind of see that again. So this is everything so far. I've got this particular reaction here, and it's wanting me to do three different things. It's wanting me to determine the limiting reactant, calculate the theoretical yield, and find the percent yield. So I'm actually going to set it up so that I'm going to do A and B at the same time because I'm going to be using our two calculation method. So I'm going to start by getting rid of my sodium phosphate. And remember, since I'm getting rid of grams, I'm going to have to use the periodic table and the molar mass to determine the number that goes on bottom. If my calculations serve me correct, it's 162.95 grams. If it's not, we're just going to pretend it is. And that is 1 mole of sodium phosphate, sorry. So now that I've got it to moles, remember my middle step in my conversion is always to use my coefficients in that mole ratio. So I'm going to be getting rid of the sodium phosphide and sodium to the sodium chloride. So 2 moles of what I'm getting rid of goes on bottom, and 6 moles goes on top. But I am not going to stop here because I'm going to go and try and answer the second question as well at the same time. So I'm going to now have to get 2 grams of sodium phosphide, which means moles has to go on bottom. And grams of sodium chloride, I misspoke a moment ago, molar mass is 58.44 grams of NaCl. I'm going to go ahead and set up the second calculation before I type this into the calculator. So the second calculation is going to look a lot like the first. The only difference is this time I'm starting with the calcium chloride. So 6.98 grams calcium chloride. I got to get rid of calcium chloride, which means I need to use the periodic table to find its molar mass. So 1 mole would go on top. Calcium chloride. This time I'm going from here to here. So 3 moles goes on bottom. And 6 moles goes on top. And as I said before, the nice thing about this is the last step looks identical for both conversions. CL. So take a moment, type it. So we've got our two calculations, conversions that we set up a moment ago, and I typed them into the calculator, and hopefully there are no calculator issues. And notice that my first calculation tells me that I would make 2.5 grams of sodium chloride, and my second calculation tells me that I'd make 7.35. Well, the idea behind this calculation for limiting reactant is that whichever one produces the smallest product, that is my theoretical yield. So this answers part B of my calculation. And my limiting reactant is whatever started that calculation. So this is the substance that we run out of first. So my limiting reactant is the 2.38 grams of sodium phosphate. It's the substance that's going to run out first. And my theoretical yield is that smaller answer. So it is the 2.56 grams of sodium chloride. Again, yield is always a product. Reagent and reactant is always the starting substances. So now we're going to actually answer the part C calculation. We go in the lab, we do this experiment, and we only get 1.56 grams. So remember, the number in the problem is my actual yield, and my theoretical is the one that was based on that calculation. So percent yield is my actual 1.56 divided by my theoretical, my calculation, sodium chloride. I would still encourage you guys to write this to make certain you're dividing the right substances, because percent yield, we're having to look at a product. Handy dandy calculator tells me that I get 60.9% yield. 375, but since every other number has three significant figures, we're just going to stop at the 9% yield. So we made 60% of the product we expected to make. Not great, but not bad. I mean, it could be worse. So this was not a very bad percent yield overall. So this is connecting percent yield to theoretical yield. I will post another video tomorrow showing the last part of this and it connecting back to these previous three. But for now, your assignment is just to do the A, B's, and C's on the limiting reactant practice. Hold off on the D's until Tuesday, Wednesday. Thank you guys. Have a wonderful Monday.